Good morning, everyone, or afternoon or evening, wherever you are in the world. We have quite a large number of people registered for today's webinar, so I want to say thank you for that. That's a wonderful way to start the new year. Hopefully, we're on to better and greater things in 2021. So I want to introduce myself. I'm Andrea Zens, and I'm one of our product managers here at Standard Imaging. On behalf of myself and my colleagues, I wanted to, again, say thank you for showing up and welcome to the first of our 2021 webinar series. So just a note about the webinar, it is being recorded, and it will be available for viewing on the website soon. Attendees are in listen-only mode, but you are encouraged to type in questions you might have, and I will do my best to answer those at the end of the presentation. Just a quick note for those of you who may be new to Standard Imaging and Standard Imaging Solutions, just a quick word. We're based in Middleton, Wisconsin. We were founded in 1989, and from our humble beginnings of well chamber and electrometer, we today design and manufacture a full suite of QA solutions for radiation therapy QA, and we are pleased to partner with you now and in the future as you're looking for solutions for your QA challenges. In case you missed it, I just wanted to say I've been with Standard Imaging for 15 years, and I've been a product manager for only a year. So let's move on now to what we actually came to talk about here today. So stereotactic goals, and if you're starting a stereo practice, what does that mean? You're looking, of course, to do safe and effective stereotactic QA for a stereotactic program, because after all, delivering just a few fractions at high dose rates can be daunting. Precision and accuracy are of the utmost concern as you care for your patients, so products that provide that should be chosen carefully. Stereotactic goals, of course, include positional accuracy, dose accuracy, validation of imaging, planning, and treatment systems. So the Lucy Phantom is truly a gold standard that's been available for quite some time, used for end-to-end testing of the entire stereotactic treatment chain. The precision manufacturing of the Phantom and the inserts allows the user to verify cumulative uncertainties of the entire treatment chain to within 0.1 millimeter accuracy. This is accomplished by using a variety of inserts with precisely known volumes, geometries, and distances for accurate measurement. We work with each customer to ensure that we are tailoring the Lucy package to your department's particular needs. Lucy is uniquely designed to lock the Phantom and inserts into place to facilitate the reproducible setup and measurement to these very tight tolerances. So along the end-to-end QA, we're talking about scan, plan, treat, and verify. Lucy is put through the same processes as your actual patient, which means, again, that the Phantom will be scanned on CT and or MRI to start that treatment chain. It's very important, therefore, to perform a variety of QA tests on these imaging systems, especially since a lot of imaging systems are not necessarily at the treatment facility. And you may not be doing the day-to-day QA, but you're going to want to do a periodic QA to make sure that stereotactic treatment chain is as tight to those tight tolerances as possible. So for the CT imaging, we have the CT marker cylinders. We have irregular volume inserts. We have a spot check of the CT densities. Again, not the full 19 plugs, but when you're doing it, you want to do a spot check. So the blue is water equivalent. You have air, adipose fat, trabecular, and cortical bone. CT scan tests may include various scan thicknesses to find the optimal thickness for your SRS imaging. spacing, distortion, and phantom orientation. Now you'll see here with the MR, we have several matching inserts to the CT inserts. Again, we have marker cylinders, the irregular volume inserts. But we have additionally, of course, an MR signal generator and a 3D MR grid. The marker cylinders for both CT and MR have a known distance of 5 millimeters center BB to center BB. And the spacing within the Lucy Phantom of these cylinders is a 60 millimeters center cylinder to center cylinder. And the irregular volume inserts have known volumes. Again, a testing and verification against known distances and geometries. So what are you going to do with these things? You're going to perform image fusion and verify the accuracy of multimodality fusion, CT to CT, CT to MR, verify object reconstruction and compare scanned object volume against known volume. And do your distance measurements. It's worth noting also that, as you see in the images here, we're using irregular volumes instead of just circles or spheres as the quickest way to really see any issues with your image fusion. After all, if you have a rotational issue, an arc on a circle is just an arc on a circle. For treatment plan QA, you can also test the following organ volumes: manual versus auto segmentation, contoured volume versus standard volume versus DVHs, dose models such as Monte Carlo, conventional pencil beam, and the treatment planning system's limitations for small fields and accessories and couch modeling. The left here, we have a plan that deliver 4 conformal arcs to the isocentric target. And on the right, we have one that's utilizing the largest of the irregular volume inserts from the irregular volume insert. Now, once you have scanned, planned, and treated it, you need to verify it. So how are we suggesting that you do that, right? So with using the Lucy Phantom, the treatment is done using film and a small ion chamber or detector. Note that the detector insert here is 1 centimeter thick. Therefore, the detector you use needs to have an outer diameter of less than that 1 centimeter. One of the unique aspects of Lucy is that we are locking the detector into place so that you never have to worry about an air gap or chamber displacement. We're locking it into the centroid. The centroid of the collecting volume will be locked into the geometric center of the Lucy Phantom, no matter whether your orientation you're using it in this way, or you can attach it so that the chamber comes out the side instead of the front. And of course, this is a 360-degree rotational base. So again, any orientation that you're using, you're not going to displace your chamber. So 2 of the best detectors to use to verify your small field delivery are the W2 scintillator with Max SD and the X-Radon A26 micropoint chamber. So the W2 is the next advancement beyond our W1 scintillator. It includes a 1 by 1 millimeter fiber with a KQ of 1. That makes it absolutely the premier measurement detector for the smallest of small fields. The X-Radon A26 is also uniquely designed with low Z materials, making it the only reference class micropoint chamber on the market without, excuse my highly technical term here, the wonky effects that other micropoint chambers have, which are available on the market. Okay, why do we do this sometimes? Oops. All right. So now I want to talk about this kit, which we call the Lucy 3D Volumetric Target Dosimetry Kit, because it's my favorite. It's also some of the latest advances. One of the things that we do at Standard Imaging is look at what the challenges are on the market. We have customers, we have OEM manufacturers such as BrainLab and Accuray or Varian Electa have particular needs, and they, for example, with the multi-mets insert, customer says, hey, I want to use BrainLab's Element software, but I don't know how to commission that. So let's develop a multi-METS insert. So this kit includes the multi-METS insert with film that you use to verify. And then we also have the target and avoidance structure insert here, where the black is high contrast bone material against a water equivalent material in order to have really good images and be able to do a very rigorous target and avoidance test of your treatment planning system, the accuracy and the limitations of those dose algorithms. You can also go through the entire workflow for a great end-to-end test using this insert. So here, for example, we have images of the C target planned for delivery, which is verified with film and microchamber. And here we have a couple of the inserts for our targets from the multi-MET insert that are planned and then verified using the criteria of 2% 2 millimeter, passing over 99%, and the dose agreement less than 2%. So very, very good, rigorous tests. Now, again, when we talk about end-to-end tests, it's not just the treatment chain, but it's also the mechanical accuracy. So we have a couple of different ways for you to do that. You can use the provided Hinden Winston Lutz target and do a scan, plan, treat, verify process, end-to-end QA there, checking position tolerances, dose tolerance, dose distribution, and then mechanical accuracy using the Winston Lutz pointer here, again, for the mechanical accuracy. Then for the Winston Lutz test, we do have our PIPS Pro stereotactic module to automate that calculation for you and give you your 3D offset. So to summarize about the Lucy Phantom, whether you're using it on its standard precision leveling base locked to the couch bar, or you lock the Phantom or pointer into the isocentric coordinate system using an interface, or you want to ensure the centroid of your detector's collecting volume is at isocenter, you can be confident that you are performing excellent SRS end-to-end QA and truly to the best precision and accuracy using the Lucy Phantom. Now that said, some of you out there are probably going, well, wait a second. We're just starting Stereotactic, so we're not going into the people's brains. We're going to start with something not necessarily easier, but we're targeting larger tumors in other organs, and very often people start their stereotactic program with lung, for example. So what does standard imaging offer you for that solution? And I would like to suggest that our stereotactic dose verification Phantom, here you can see it with the heterogeneity slabs, is an ideal Phantom solution. We have the respiratory gating platform for motion management. We have our Winston Lutz pointer with 3D micrometer and tools such as our Supermax, and again with detectors like the A26 diodes or our W1 or 2 scintillator are fantastic tools for that SBRT program. Our Supermax electrometer, like I said, is an I just want to mention, is actually a very versatile electrometer. You get a lot of bang for the buck with that electrometer. I will say, being dual channel touchscreen, high and low ranges, ratioing, lots and lots of advantages to using that as part of your stereotactic, whether it's SBRT or SRS, as an electrometer for that program. And here I wanted to just show you with the versatility of our stereotactic dose verification Phantom, which is a 20 by 20 Phantom. So it's easier to manage, easy to set up. We're locking things into place so things don't slide around. There are embedded fiducials in the Phantom configured in a nonlinear, non-coplanar fashion to create an isocentric volume. Our chamber plug also has gold fiducials, which are, again, closer in because they're on that plug, so that's better for the smaller tumors that you're tracking. The QA slab hard to see it a little bit here, but you'll notice, and it was highlighted on the previous slide, you'll recognize those from the Lucy Phantom as well. Target and avoidance structures, and again, the spot check of your CT densities. And then here we have the lung slabs, which also have embedded fiducials, which is wonderful for your Monte Carlo type calculations. And this is a Phantom at a much more reasonable price point than a lot of them that are out there that include lung material. So then, of course, the next question you might have, leaving you scratching your head, yes, we can use detector and film with the Lucy Phantom or SDVP. Those are great. But there's a push in the world to talk more about patient QA. How do I make that simpler, faster? So I'm just going to mention quickly our patient solution that will round out your stereotactic program. Here I'm talking about our Adaptivo, which is pre-treatment, in vivo, and adaptive. So it doesn't stop where others do. It actually offers a whole module further for you to be able to really verify, again, if few fractions, high dose rates, whether you're on track to treating the patient as planned, verifying, you can capture setup and delivery errors, patient changes in patient geometry, and you're tracking those cumulative 3D dose distributions, automatic DVH analysis. These are really important tools that run and help you. And the other thing, because we also know that log files are of great interest. You have those on your machine. What can we do for you as far as that goes? LinAcView is our log file-based patient QA solution. The overview of the workflow of that software is here. You have an approved plan that is exported both to LinAc and to LinAcView. And then LinAcView is watching when it receives an RT plan. Log files are generated. Delivery of that plan will automatically be associated with the plan and analyzed each time the plan is delivered. And LinAcView provides you a lot of information that is very useful in order for you to investigate, understand, and address any issues that you might have with the patient. These are definitely tools for the physicist, but before the patient even leaves the table, the therapist is going to have a view specially, designed for them that gives you the pass, alert, fail information that allows you to, call attention to it before the patient even leaves the table. So that was a whirlwind of information for y'all. So if you do have any questions, please go ahead and put those in the chat. I'll give you guys a minute or two to do that. And I'll open up my questions here to see if I see any come in. And I also just want to indicate that you guys are most welcome to go to our website. I highly encourage people to create a sign-in so that you have access to our customer portal, which has a wealth of information about all of our products. You can also sign up for more webinars that are coming up and listen to recorded webinars that have previously been delivered. Again, if you have questions that you think about once we're offline together here, please do reach out. You can reach out to sales@standardimaging.com, or you can reach out to myself at azens@standardimaging.com. We are here to help. We are here to make sure that you are doing the best that you can do with tools that are efficient and streamlined and automated as much as possible. These things are really important as you guys are asked to do more and more with your days. I think I do have a question here. Do you have a multi-met verification tool? Sort over there. How do you measure the dose aggregates in one plant? So how are we testing the multi-mets? As I showed back in the slide, the multi-mets insert, let's go back to that slide. It has 5, where are we? There. So this first insert here that I'm showing, it has 5 embedded targets in it. They are also placed, nonlinear, non-coplanar, so that you can plan across. And then using the film insert that we have over here, you can the multi-met's targets are positioned in such a way that putting in a certain number of film spacers, you're going to align film across the center of those targets and verify that via film. That is the best way to do it. And then using also, in combination with this insert on the bottom, you see here, the hidden Winston Lutz target, which is provided with the Phantom. Also use that so you have your 5th target. And again, you can use a detector and or film at that central target to verify that plan. So I hope that answers that question. And that seems to be the, hang on, whoop, maybe there's another one. What is the maximum separation of these? I do not know this at the top of my head, but that information is available in our manual, which again, if you log into our customer portal, would be available for you. I don't see any other questions. So with that, I'm going to say thank you ever so much. Oh, wait a minute. So someone asked, can I talk about analyzing film? You can use our product, which is the Ray Film Dosimetry software. You could also use RIT. There's also Film QA from Ashland themselves. Our Ray Film Dosimetry software comes in a 2D and a 3D version. So very useful in this day of wanting to view things in a 3D version. So that's what I would recommend to you for that. And I think that I've hit all the questions. So I'm going to say thank you. Thank you all very, very much for attending today. It's been great to have you here and kick off the new year for great things for all of us. Again, if you have any questions, let me know. Have a great day or evening, wherever you may be. Bye-bye.